Okay, so guys, here we go. Let's get started. So you can have plenty of time, ask questions if you need to, and maybe if you're smart about it, you could start working on your review. So remember, eyes quiet. You should have your notes out and be listening. I made these available to you yesterday. If you didn't get one and now you're ready for one, or you weren't here yesterday, they're on the cart. Okay, don't get up now, but this is your review. The key is on Canvas. Okay. And it's exactly like the test. Same number of problems, same drill as always. You know, I'm not here to trick you or anything like that. But I would start thinking about getting it done. Next week's a busy week, okay? Not just for us, but juniors are taking the SAT on Wednesday. It's the end of the quarter, right? So I'm guessing you have other teachers besides me giving you tests next week. Lots of things due probably. So get focused and think, okay, I got to get through one more week and then I have spring break. And how am I going to end it strong? Because when you come back, we're in the final stretch. We're in fourth quarter. I can't even believe it's here already. All right. So as far as this class's schedule goes, remember what's going on. We have today 3.11 day 1. Monday is 3.11 day 2. Tuesday is the day we do this in class. Wednesday I won't see you guys because I'm proctoring the SAT. Juniors will be taking the SAT. If you're in this class, and if any of your teachers are proctoring, there's only like 10 of us, but I'm one of them. If you're here on Wednesday and you're not taking the test, you'll be in the auditorium for me, where they'll take attendance and stuff. So just if you're wanting to exempt, don't use it as a skipping day. So I won't see you guys the day before the test. That's why Tuesday's a big day in this class. Don't wait till Tuesday. I would start looking at it now. You have time in class today after the homework and stuff. And then the test is Thursday. Okay, so plan on taking the test next Thursday. The key is up there since yesterday, okay? Yeah. Yeah. Is it our last day of notes, guys? A, and then we have B. So 3.11 day 1, 3.11 day 2. Neither one's hard, okay? Neither one is hard. All right, so let's get started. And we're going to have our last homework check of the quarter on Monday. Last homework check Monday. All right, so what we're going to work on today is secant, cosecant, and cotangent. There are a total of 6 trig functions, and we've been working a lot with the first 3, the most common ones, sine, cosine, and tangent. They have friends. I call them their friends to help us kind of memorize them. Secant, cosecant, and cotangent. They are called reciprocal functions. So reciprocal means flip. So if you understand who the friends are, so cotan and tan are friends. Cotangent, tangent, nobody mixes those up because it has the word tangent in it. So if you take tangent or you take cotangent and flip the other one, you get the other one. Okay, so they are reciprocals of each other. Cosecant and sine are friends, and secant and cosine are friends. And students get those mixed up all the time because you have to know, it's really important, who the friends are. Okay, so I have this silly little saying that I use to help you guys remember, and that is every C needs an S, every S needs a C. So you don't put together the 2 C's. Like cosecant and cosine do not go together. That would, well, if you have it. Okay, but yeah, thank you. Cosecant and cosine don't go together. It's the C and the S and the S and the C, okay? And so you'll see me doing that over and over again today. So understand, we have a quick sketch of the unit circle done for us here. All of the points are X and Y, or cosine and sine, right? We know this is cosine and this is sine. And so sine, cosine, and tangent, we know sine is Y and cosine is X. Tan is Y over X, or sine over cosine. We need to know all these things, and I think we do, especially these 2. And then cosecant, friends with sine, every S needs a C. We flip it. Flip. Flip. Okay, when you flip something, you're just putting it in the denominator, just taking whatever it is and flipping it. And we actually don't do much of the flipping today. That'll be Monday, but just understand the concept. Really today it's who goes with who. Sine and cosecant go together, cosine and secant go together, and then tan and cotan go together, okay? Let's see what I'm talking about, because the graphing of these is really, really easy, okay? Really, really easy. In fact, this is basically for the most part, a review of sine, cosine, and tangent. So it's kind of nice. Every time I teach these three, cosecant, secant, and cotangent, it's just a really nice review of sine and cosine, because if you have to graph sine and cosine first. So when we graph cosecant and secant, they're the reciprocal functions of their friends we just talked about. We can use this concept as an aid in graphing. Each reciprocal function behaves as a skeleton for the graph in question. So let me show you what I mean. So cosecant is friends with sine. So we actually start by graphing his friend, y equals sine x. Okay? So let's think back to what we know about sine. Sine has a period of 2 pi, and it has a pattern of middle, up, middle, down, middle, right? Middle, up, middle, down, middle. And I'm going to repeat it one more time. So what I have here outlined for you, don't connect it, what I have outlined here for you is 2 periods of the graph of sine, the parent function, right? A is 1, there's no period change, there's no phase shift, there's no midline, okay? And what you're going to do is just connect them with a dotted graph, okay? And now we're ready to graph cosecant. Really, really easy. Everywhere you see an x-intercept, so here, 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 everywhere you see an x-intercept, we have an asymptote. So I'm just going to put my asymptotes on there, showing it with a dotted line, dotted vertical line. And everywhere I have a max or a min, here's a max, here's a min, here's a max, here's a min. You make what looks kind of like a parabola. I don't want to call it a parabola, so I gave it its own name. I call it a curvy. It's curved. It's got arrows on the end. These are called branches. The branches are reaching out towards the asymptotes, but not touching them. And they go up forever and down forever. And that's it. That's the graph of cosecant. Now, of course, we can throw amplitude changes in there, flips, change the b value from 1 to something else, which will change the period. We can put phase shifts in there. We can put d's in there. And we'll practice all of these things together. So really, you're reviewing everything here, which is really, really makes it, like I said, a really good lesson. Now, I'm not going to go through all these things except this one. I like talking about the range of this graph because you might see it on your test review and your test. And so let's talk again about what range, well, back up for a second. Domain is all real numbers except where you have an asymptote, right? I just don't like the notation they use for it. So think about it. You can have any x value except where there's an asymptote. Those are undefined values. You can't have a point on an asymptote. That's the point of it, right? And then range, think about it. These arrows point down forever. So negative infinity up to what number? What number does it stop at? What number does it be? Negative 1, right. So we go from negative infinity to negative 1, and we use negative 1, right? That's where our mins and our mins are, at negative 1, right? That's what those points are. And then we take a little break. We don't have any y values in between here. We start again at 1 and go up forever. And I always like to kind of look at a graph to state domains and ranges. It just makes it easier to have the picture to look at. So it's like number 2 on your test review is a question like this. And if you look at the key, which I have on Canvas, like I said, I just kind of sketched a graph. I didn't get a graph paper or everything. I just kind of drew the graph, and anywhere an asymptote was my answer. So you'll see what I mean when we get there. Okay, let's review what cosine graph is, because cosine is the reciprocal of secant. SC. The period is 2 pi. So again, I'm going to sketch out the graph of cosine. And I just have to remember it starts up. Up, middle, down, middle, up. So that would be up, middle, down, middle, up. Same thing over here. That's our skeleton. We use that to find where the asymptotes are, because it's the same exact thing that we just did. Where do my asymptotes go? On my x-axis. And my curvies are going to go right off of the mins, and maxes. Now, typically when we graph cosine, also known as secant, we cut off curves. Because if you look, I have a point here at a max at negative 2 pi, but it cuts it off, so you can't use the other half. So you have to kind of see, oh, it cut off there, same thing there. So we have a partial curvy. That happens a lot. Range is the same. Me being lazy. That says same. Really lazy. Okay? And again, the domain is all of these numbers except anywhere you have an asymptote. Asymptotes represent places on your graph that you can't put any point. Okay? So let's add some transformations in. Here's where we're going to review. What happens when you change A, B, C, D by the time we're done. And we'll cover everything in the homework together. Okay, so first thing I want to notice is if I have to graph cosecant, who do I start with? Sine, right. So I'm actually going to graph this graph. We can call it the skeleton graph, whatever. We're graphing this, and then we just do our asymptotes and our curvies. Okay, so we have an amplitude of 2. Okay, remember that just changes. Instead of going up and down to 1 and negative 1 respectively, we would go up to 2 and negative 2. And our B value is 1/2, right? B is 1/2. That will affect the period. So our period of the parent function for sine is 2 pi. But if you have a B value, we divide. So that's keep, change, flip, we get 4 pi. So let's recap what we've learned before. When the period changes, that stretches or shrinks the x-axis. It's a horizontal dilation, but we still start at 0. The only time we don't start at 0 is if there's a phase shift. And a phase shift looks like a plus or a minus going on inside. And we'll hit one in the homework together, okay? So you'll get to practice that. But these just start at 0, go out to 4 pi. So I'm going to put the skeleton graph of sine, which is middle. I'm going to go up to 2 this time. Up, middle, down to 2, middle. So there's one period from 0 to 4 pi. And I'd have the same thing over here. Middle, up, middle, down, middle. And someone asked me last period, do I have to make the dotted? No, you don't. It helps me. But if you don't want to put the dotted graph there, that's fine. You should still be able to see where your x-intercepts are, right? Everywhere your graph touches the x-axis, you're going to have an asymptote. A whole bunch of them here. And then at your maxes and your mins, you will put your curvies with arrows on the ends. Question on that one? Okay, secant would be cosine. Gotta know that. SC. Okay. We have a flip. We have an amplitude of 2. We have a B value that's not just 1, so that changes the period. So that would be 2 pi divided by B, which is 3. So no phase shift, no left or right. So we start at 0 and go to the right 2 pi over 3. And we'll go to the left 2 pi over 3 and just do 2 periods. Okay? So this is cosine, which normally starts up because of the flip. We start down. So starting at 0, we're going to be down at negative 2. And I'm only going out to 2 pi over 3. So sometimes when they change, like especially with these weird fractions and stuff, I might think, okay, it's middle, down, middle, up, middle, down. So I'm going to end at the same place I started. Sometimes it's just easier for my brain to kind of map it out that way instead of just going willy-nilly left to right. So there's my end points. I'm going to have an up right in the middle. And then, okay, there we go. I mapped out one period. And I'll put one over here as well. So at negative 2 pi over 3, I would have another end. And then So there is there is a flip of my amplitude of 2 cosine, 2 periods of it, and now the actual graph of secant is just filling in anywhere I have an x-intercept. I put my asymptotes. You gotta wonder where they find this stuff out. Those old people, how they figured all this out. And then we have our curvies, and we're usually going to have a piece of a curve on these graphs. So, like, when in doubt, just think, okay, where would it be if I could continue it, right? It would match up with this one, but I can't go to the left. So it's only going to be on this side, the right-hand part of the graph, and here would be the left-hand part of the graph. So you don't want to go past your period. We good on secant and cosecant? Wake up your friend. That's my feelings. Like a tear comes to my eye when I see their head. This is fascinating stuff. How could you sleep during a lesson like this? Gosh. Good gracious. Okay, last one is cotan. I'm going to make this nice and painless. Blah, 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 blah. Okay, let's just graph the parent function. Then I'm going to do one with a whole bunch of stuff thrown in, and then we'll go to the homework. Okay? So, cotan. This doesn't have a skeleton graph. This is where you have to remember how to graph tan, and then cotan's the same thing except 2 little changes. Okay, so let me remind you. With tan, what you had to remember is it had a period of pi, and I don't know what an abbreviation for asymptotes is, but you get the idea. You had asymptotes from negative pi over 2 to pi over 2. That's memorization. We have to know that. Okay? And then if you remember, I called them squiggles in the middle. And tan squiggles just followed the same exact end behavior as lines. So if tan was positive, it would squiggle in this direction. And if tan was negative, it squiggled in this direction. Okay? Here's cotan. Cotan has a period of pi, just like his friend. Okay? Remember, sine, cosine, and their friends are 2 pi. Tan and cotan, pi. And the asymptotes are different, though. They're from 0 to pi. It actually makes the math easier, you will see. And they squiggle in a different direction. Okay? Cotan squiggles the opposite direction of tan. So if positive tan squiggles this way, positive cotan squiggles this way. They're the opposite. Okay? So let's go out to, let's do 2 periods. So I would have asymptotes at 0 and pi, and then 0 maybe in negative 2 pi, or I could have gone out to 2 pi. It doesn't matter, right? They just keep repeating. And if you remember how to graph tan, really simple. Same with cotan. You'll have an x-intercept right in the middle of your period, and we squiggle the opposite direction. So positive cotan actually squiggles like this. So if you guys missed the days that we learned about tangent, you just learned it pretty much. Right in the middle of cotan period, again, these squiggles, my word, not a real math word, they squiggle the opposite direction. So that is positive cotan. Positive tan. Okay? So let's do one that's got a bunch of stuff added on. Okay? Look, we have an a of negative 1. We have a b of pi over 2. And we have a d of 1. What do they want to know? You want to know the period? Fine. That's pi divided by b. Sine and cosine was 2 pi divided by b. Keep, change, flip. So that's pi times 2 over pi cancels. We get 2. Okay, so that means from 0 to 2 is one of our periods. But we normally aren't asked period on tan and cotan. We just graph everything with asymptotes. This is a reminder of how to do asymptotes with tan and cotan. You take your argument. Remember, the argument is whatever's in parentheses. And you plop it down right in the middle of your asymptotes. Remember with tan, it was negative pi over 2 to pi over 2. With cotan, it's 0 to pi. And remember, we solve for x. I'm going to multiply by the reciprocal. Here's why it's easier, right here. If you multiply anything by 0, it doesn't change, right? You still have 0. Really easy to graph from 0. And then over here, we get 2. Sorry, it's really messy. So just like we said, the period goes from 0 to 2. Let's put another one on there, maybe going in the other direction. So we map out what part of the x-axis we're going to use. I need to pay attention to the fact, I'm almost done, guys. I need to pay attention to the fact that I have a midline. Remember, that just moves your x-axis up 1. So any way I graph now, I just pretend that blue dotted line is my new x-axis. So that's the middle. My x-intercept is now right there. And it's a flip. So positive cotan normally goes the opposite of positive tan. So negative cotan actually goes this way. So you can see how, like a multiple choice, you would have to remember all those little details. That's the bad thing about multiple choice, guys. That's right. Yes. Because if I were giving you a test where I gave you some graphs, you had to fill it in, I'd be like, okay, I can give them a point if the asymptotes are right, a point if they flipped it, oh, they graphed tan instead of cotan, okay. But with multiple choice, it's right or wrong. So even though some parts are easier about multiple choice, some things you almost have to memorize more and know more. Yeah. Yes. I'm so sorry. Yes. This is the one I was just giving a hard time for having her head down, and that's what it should have looked like. I'm so sorry. I missed that asymptote. It was from 0 to 2. I'm going to do it on the homework with you, and I won't mess it up. 0 to 2. Sorry about that. So right in the middle of that period, you had that x-intercept, and then to the right and the left. And then this is 2 periods. So I apologize. Hopefully you guys are using pencils, or write yourself a little note. Okay? Thank you, thank you, thank you. Good? Ready to go homework? Okay. Sorry about that. Yuck. This was my recorded video, too. So hopefully the people watching this video paid attention. Okay. So here is our assignment. I'm going to do 5, 6, and 7 with you. It's one of each type. And then 4 problems on your own, the odds. And I'll put the key up and answer any questions. Should have no problem finishing that in class. Guys, why are you grabbing your phone so soon? It's still working. Come on. Come on, come on, come on. All right, starting with number 5. You sure? Oh, Jana, we're doing a quiz today in that class, so it's probably not a good one. Unless you sit somewhere else. It's just because she'll be good. Okay. You guys call each other out all the time. It's so funny. Okay, so guys, we're graphing secant, which is, who's the friend of secant? Cosine, yes. Now look, C over B, I feel like we've talked about it, but not enough. C over B is a phase shift, okay? And so this would be pi over 1 or just pi. Phase shift is what's in the parentheses, the C over the B, okay? But we don't have one. If there's no plus or minus in parentheses, we don't have a phase shift, okay? 2 pi over B, that's our period. Our B is 1, right? The number in front of x, so it's just 2 pi. So I'm going to start out by graphing inverse cosine, so the negative, or the flip of cosine, I should have said. And we're going out to 2 pi. We're going to graph 2 periods. Oh, except for number 11. Write yourself a note. Just do 1 period of that one. It's really kind of funky. But anyway, So I'm going to go, instead of doing, so I think of cosine up, middle, down, middle, up, I flip it. So that's going to be down, middle, up, middle, down. And I'm down at 1. So down, middle, up, middle, down. And I'll do another one over here. And put the dotted on there if you want. Remember, it's curvy, not pointy. That's it, right? Then you just put in your asymptotes and your curvies. And remember those end parts. Just be careful if you need help with them. Oops. Apparently I do. If you need help with them, ask somebody besides me. Just kidding. So we're matching this one that we're cut off. Okay? With cotan, it's in tan. Remember, we just do the asymptotes. We don't really have to worry about it being a phase shift. We just take our argument and we plop it right down in between the asymptotes. If it were tan, it'd be negative pi over 2 to pi over 2, but cotan is 0 to pi. How do we get x by itself in this one? Minus, right? Minus pi, minus pi, minus pi. So 0 minus pi is negative pi. Pi minus pi is 0. So our left asymptote is negative pi, our right one is 0. So there's our first period. We need 2. It doesn't matter. You can go out to negative 2 pi. You could go from 0 to pi. Either way, it doesn't matter. Let's see if I can do this one right. Okay, so I'm going to have an x-intercept dead center in each of my periods. And cotan, so I have to talk myself through it. Cotan positive goes this way. So negative would go this way. Okay? So here, 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 here. Good? Does that make sense, Olivia? You look like you're like, no, perfect. I shouldn't try and analyze your facial expressions. Okay, next one. Let's do number 7, and then I'll shut up. Okay, this one has a phase shift. So I like the problems I picked here because it's kind of hitting every different type. So remember, this is your C value, C over B. So it's pi over 1, and it's to the right, opposite. So it's pi. 2 pi over B. B is 1. That's just 2 pi. Okay, so if you have a phase shift, these are the worst ones. Whenever you have a phase shift on sine or cosine, it doesn't matter with tan and cotan, it just moves your asymptotes. But with sine and cosine, which this one is sine, anytime you have that, that's where you start, okay? So we can either start right or left pi, honestly. I'm going to go ahead and just keep it with what I know with h and k, with the opposite, to the right pi, okay? That's where I start, and then I do my sine graph. So from here, I would go, no, I just want to get this wrong. No, I didn't. Okay, so from here, going to the right, it would be middle, where am I going up to? 1, middle, up, middle. That's it to the right. So going backwards, I need a min and then another middle, right? So that's one period, but it started here, and then I just kind of worked backwards. So then I'm going to match that with this. So phase shifts are a pain. It ends up filling up 2 pi to negative 2 pi, but we had to start to the right, so it's all kind of weird. But after that, we can now just put all of our little pieces in. Okay, so we have asymptotes, and then your squiggles, your curvies. So phase shifts create a new starting point other than 0. If there's no plus or minus in the parentheses, you start at 0. Okay? Now you're going to go to 9, so the next one, 9, 11. Number 11 is the one I said just do one period of it. You'll thank me later. This is 7 through 9, that's one that you missed, so back into this. Do you need to see those first few? Maybe it'll help you. C over B is your phase shift. So it's, if you look at the next problem, or look at number 9. Look at number 9. Yeah. Remember, I didn't wait till the last minute. Again, next week's going to be very busy for us all.